Okay, so now that we know what logical and relational operators are, we can introduce conditions and branching. So you have int if, not int statements, you have if statements. The syntax is the following. So basically you type if, and then you open up parentheses, you write out a condition, and depending on what that condition is, it can be an entire expression which needs to be evaluated. It can simply be a number like 0 or 1. It can be true or false, whatever. Based upon the evaluation of that condition, you have something that happens. You have like code goes here. So if the condition is true, this code will be executed. Now you of course can create like else and else if, etc. You can create multiple conditions depending on what happens, but I will show you that in a moment. For the time being, I wanted to go with something else first, with simpler things. So we'll need int x. We will assign it a value of 10, and we shall redefine our condition here. We shall state that x is greater than 6. Okay. Well, I suppose you can see it better like this. No big deal. I'm trying to find an optimal way to write the code, not for my own convenience, but so that when you are looking at it, you can see it in a very clear way. Anyway, so code goes here. Okay, let's play some code. So this will be executed if x is greater than 6. Let's type in std, : cout, x is greater than 6, and I don't know, std, : and L. Let's put it out like that. So if x is greater than 6, this will be printed out onto the screen. Here you can even convince yourselves of that. You see, x is greater than 6. Change this to 1. Let's go ahead and run it. Oops, nothing happens because x is not greater than 6. Okay, let's change it back to 10. Down below, we can have another way of putting another if statement. Let's just recycle this. And we can simply state if 10, type in here, 10 is also true. Okay, obviously, this is true. Why? Well, as I said, 0 is false. Anything above 0 is true, is evaluated as true. Therefore, this will be the same as me writing true here, or any sort of a condition being evaluated to true. This will be printed out onto the screen. So, yep, 10 is also true. Hey, wild guess. Who knew? However, here's a well, I'm not going to call it a trick question, but if -4, well, let's put it like this. Let's recycle. Recycling is good for the environment. So 10 -4, and let's. So shall we say that this is false? So shall I change this state? Shall I change it to right here to false, or will it say -4 is also true? So what do you think? In your professional opinion, do you think that -4 will be evaluated as true, or will it be evaluated as false? Think about it. It's actually a little bit counterintuitive, but if you build and run it, you will see it. -4 is also true. So it -4 actually evaluates to true. I know, it's a little bit weird, but no big deal. Okay, so you got if 1.5, and let's see what happens here. Okay, more recycling. 1.5. Do you think that 1.5 will also be true? So it's 1.5. Well, I'm going to have to rename this. Everything not 0 is true. And that should answer this one and all the future questions in regard to what sort of numbers are evaluated as true and what numbers are evaluated as false. So everything not 0 is true, be it a minus, be it a decimal, be it a positive number. It's really not that important. So if I type in 10 is greater than 5, what do you think this will be? Is 10 greater than 5? Yes, it is. So, true. Okay. Okay, let me just scroll down my notes a little bit. However, you see, this evaluates to true, and okay, something happens here, and this evaluates to true, and something happens here, and so on and so forth. If I placed a 0 here, nothing would happen. The code would not get executed. Here, in fact, let me just be thorough and explain that and demonstrate that real quick. Pointless text that will never be printed out. So yeah, here we go. If I just run it, you see x is greater than 6, 10 is also true, minus 4 is also true, everything not 0 is true, and true. What was true? Right, 10 greater than 5. And if 0, you see, pointless text that will never be printed out because this condition will not change, it will remain 0. It's not a variable, it's a constant, and we have written a number here. Anyway, so it evaluates to false and nothing happens there. But now we would like to have a way of actually doing something if the condition is not true. So if it's true, do one thing. If it's not true, do another thing. That's the idea. So I'm just looking for the code to recycle. Yep, let's go ahead and copy this one. So x is greater than 10. X is greater than 10. But in case it is not, I would like to have an else statement. Actually, this is not in case it is not. Else if, and then a condition would be, and then to specify a specific condition where x is not greater than 10 would be a more thorough way of doing this. But if you write else at the end, that means as long as this condition is not true, else will be executed no matter what. So std, well, not no matter what, but you get the idea. So if x is, for example, equal to 10, or if x is lesser than 10, else will be executed. But I will show you the examples with else if as well. So no worries there. I don't know, cout. Yeah, I might as well actually write it. X is not greater than 10. std colon end L. Excellent. So this is gonna go ahead and happen in case x is not greater than 10. So it can be equal or it can be less than, but you can create this. So you can cover multiple conditions in this fashion. However, let's take a look at something, and I would like you to tell me if there is a mistake here, if this is possible. So just take a look at it, think about it, and then come to a conclusion, and then I'll give you the answer. Pause the video if you must. Okay, so we're just gonna go ahead and use the same example here. Didn't want to write a different example for each one of these because it's fairly similar. And if I write here something random, like int y is equal to 10, and then I just put this below. So this is not going to work. If I compile, oops, nope, it's reporting an error immediately. If I just comment this out, and if I run it, yep, it's fine. It's going to run without any problems. So you can't really place anything in between these. You must keep them clear, one after another. No other way. You cannot just insert random things in between them. So if we have only one statement, we can even omit these curly brackets. So basically, for all these initial examples, the curly brackets were completely unnecessary. If I type in, I don't know, x is greater than 2, I can type in immediately std cout. Okay, x is greater than 2, std and l. There we go. So that's it. But if you have more than one line that needs to fall under the if or else statements, you will need the curly braces. If there's only one line, you do not require them. This is valid both for else and for if. You see, I can actually remove them here and here, and I can run and build and compile. You see, it runs. It's all good. If there is one, but if there is more than one, it might compile again. It probably will compile, but that something will not be taken into consideration the way you want it to be taken into consideration, depending on how it is written. So it might compile and it might not compile. For example, if I have this line of code, and if I place it here, and even if I move it like this, this is gonna run. This is gonna build and compile without any problems, but this will not fall under if. And as you saw here, if I put something in between if and else, we're going to have problems. Anyway, so hopefully that part is clear to an extent. But, in case it is not, you're always more than welcome to ask questions. Now, let's go ahead and do something different. Let's delete all of this. Not going to need it. And even this. We shall type in int age. We will leave it uninitialized. We will leave that to the user. Cout. Enter person's age. Okay, fantastic. std : cn age. I'm gonna get some input from the keyboard, and now I would like to give different outputs based on the age of the person. So the age of the person, it can be, I don't know, you can have a 3-year-old, you can have an 18-year-old, you can have a 13-year-old person, you can have a 30-year-old person, you can have a 50-year-old person, etc. So you have a wide variety of these conditions. And if and else is simply not enough. You need more than that. So if you type in if age is greater or equal to 18. Let's say that this is considered an adult person. I mean, legally it is. Cout. And we can say person is an adult. Unfortunately, you need to be 21 in the US to be able to legally buy alcohol. However, this is so untrue of my own country, where you can be, I think, 16 or 18, something like that. I'm not sure. It's 18, I'm pretty sure. STD, : and L. So that's one. But we, what you cannot just place else and for every other number that somebody would enter for somebody's age. I mean, that would not be very precise. So instead, we will use else if. We'll type in else if, and now we will issue another condition. So age, if it's greater than 13. So the first condition is false. That is, age is less than 18. So you see, if the person is like 15 or 16 or something like that, and it's less than 18 and it's not equal to 18, it will jump into this condition here, and then it will check whether the age is greater than 13. And we shall type in std cout cout person is a teenager. Okay, so hopefully I spelled that right. If I didn't, forgive me. : and L semicolon. And now we can practically give an infinite amount of conditions down below. Type in else if age is greater than 3. So yeah, if age is greater than 3, so if this condition is false and if this condition is false, then go ahead and jump into this condition here. You can, as I said, you can have quite a lot of them. std : pretty much as you want. I'm not aware of any limits. There probably is a limit somewhere. Person is a kid. Okay. std : and L semicolon. And down below we will just type in else in case it's any other number that doesn't fit in this range at all. I can just go ahead and type in std : cout. Well, what do you think? What do you think is the age of a person whose age is not greater or equal to 18? It is not greater than 13, and it is not greater than 3. Well, I'll give you one hint. It's a baby. Joyous news for some, sad for others. Depends how you look at it. std : and L. So, there you go. This is how you can split it out and branch it to multiple conditions. You can have, I don't know, else if for whatever, and else if for whatever again, and then else at the end to cover anything that you might have missed, some general case what will happen. Anyway, gonna bid you farewell here, and we will continue up in a follow-up tutorial.